It's very hard to imagine a bridge that was going to completely overshadow the existing bridge.
We, the port, took on the responsibility of clearing the right-of-way. The reason for that is there's a lot of previously abandoned oil wells or active oil wells, a lot of utilities in the right-of-way area.
These wells are right in the footprint of the bends of the new bridge, so we need to remove the well casing way deeper than we usually have to. So this entire thing that you're seeing here, it's never been done in our industry before.
In one case, we had to send divers down 250 feet down a narrow shaft, had to put them into decompression chambers to avoid the bends afterward.
We have to do these casing recoveries from about 240 feet below the current surface. So what we do is we take this 2.2 meter pipe, and which is approximately 7 feet, and we oscillate it down to a section where we're going to cut. And here you can see we've just cut and recovered part of the casing that was in the well.
That was a very early challenge. At the same time, we're spending a lot of money on the foundation, and the Harbor Board and members of the city are saying, where's all this money going? We don't see anything coming out of the ground. So it was, it just made it that much more important to communicate what was going on and what we were doing early on.
One of the biggest surprises, something that went extremely well that I thought was going to be a humongous challenge, was the installation of the foundation piles.
We ended up building incredibly deep, strong, what are called cast and drilled shaft piles. And these things are enormously deep. Some of them are 200 feet deep. And there were so many of these, we found out the complexity of this, and to make those things work for the seismic design loads, it was incredibly challenging.
We have an opportunity here to see what some of that structure that goes underground looks like when it's up in the air. This is the steel reinforcing cage that's going to be placed down into one of those deep piles. Then the concrete will be poured around it. This steel weighs 66,000 pounds. And remember, there's over 300 of these piles that's going to support our bridge. That's the kind of work you need to have a bridge that's going to last 100 years.
The contractor had to install them in a manner where they had zero defects, zero flaws from tip to top. And we verified this through various types of gamma testing, which is a radiation testing or a cross-hole sonic logging type of method. And we were able to see inside of the pile, inside the cross-section of the pile, and ensure that there were no anomalies, no defects in the pile.
Certainly, the success of the project early on hinged upon the ability of the contractor to drill 350 holes in the ground in a relatively short amount of time, and to do it accurately, because that really is the foundation upon which the rest of the bridge sits. So the bridge drilling foundation crew, legacy drilling, they really were rock stars on the project.
The pile cap of the tower was awe-inspiring, because that was the culmination of all the work that went into the foundations coming to the surface, and the realization that what I was looking at was going to be supporting the tower, which would eventually be supporting the entire bridge itself.
When one thinks of all the steps that have to take place to bring the site from a bare, clean dirt site to this massive billion-dollar structure, it really taxes your imagination.